Okay, theorem 2, where we need to prove that the diagonals bisect each other. So we have a parallelogram ABCD. Okay, now remember, if they don't give you the parallelogram as a starting point, then in your proof you can write down draw parallelogram ABCD. Right, now remember, from there, okay, you write your required to prove. Also just write down proof and indicate one time while you're there, indicate that you are constructing the diagonals. So construct diagonals, and this would be A, C and B, D. A, C and B, D. So let's draw that in. A, C and B, D. Okay, so our required to prove, coming back to that, would be, and we'll call this E. Let's call that E. So now it would be better for us to do the required to prove. So this would actually be to prove that AE is equal to EC, right? And to also prove that BE is equal to ED. So now it's clear for us to see which lines we are speaking of. Okay, now we can continue with our proof. So the best idea when it comes to this would be to use congruency. So let's indicate our triangles that we will be speaking of. Now we are speaking of the diagonals, so let's take the smaller triangles instead of the bigger ones. So the smaller triangle would be ABE, triangle ABE, and triangle, the opposite smaller one would be triangle CDE. Right, so the first thing we'll indicate from these two triangles for congruency would be, right, to indicate the angles. Now remember, when we're indicating the angles, we need to label our angles. So let's make it easier for the marker and say, marker, we are labeling our angles, and we will indicate to you which angle we are speaking of, because like I've mentioned in previous videos, even though we're speaking about angle D, but there are two angles just for angle D. There's D1 and D2, so we need to be specific when we speaking to the examiner. Okay, so let's look at this. Now we are looking at the triangle. Let's make it a bit easier for you. So we are basically looking at this triangle here, right, and the other triangle would be this triangle here. So we are talking about these two triangles and showing their congruency, right? So let's look at triangle ABE. If you look at it, we can see clearly that A2, right, you see it's in the triangle, A2 is equal to C1. And what is this? This would be alternate angles, right? And remember, with alternate angles you must indicate the parallel lines. So it would be AB is parallel to DC. Okay, the second thing we'd indicate would be B1. Similarly, B1 is equal to D2, angle D2, and this would also be alternate angles, and that would be, let's look at the parallel lines. That would also be AB is parallel to DC. Now the third thing, remember, there must be three things for congruency. So the third thing would be to indicate the sides. All right, now if you look at the two sides, they are opposite each other. That's AB and DC. Those are equal because they are opposite sides of a parallelogram. So we'll have AB is equal to DC, and this would be opposite sides of palm. Right, so now that we have that, we'll say therefore triangle ABE is congruent to triangle CDE, and we would use the reason side angle, right, or some people call it as angle side, and one of those two you could call it, right? Now once we got that, we say therefore Now let's look at it from this congruency. What do we determine now? Now that we are saying that these two triangles are equal, so we can clearly say that BE is equal to ED, and we can say that AE is equal to EC, and they basically proved what we had to do right at the top.